Yes, hello everyone. Again, I'll be sharing to you another video, and it's gonna be a program that will be. I'll try to apply recursive function programming. Okay, a very challenging topic and concept, and um, personally, I love the topic. Okay, I love challenges. By the way, okay, you know, in programming, if you just know how to tire yourself and don't get tired, then that's the best formula in programming. Okay, get tired of yourself, but please don't get tired. And and tire yourself in programming, but don't get tired. That's my way of mind setting, right? uh, I am going to discuss we'll try to create a program out of this particular programming problem, and along the way we'll try to apply the recursive function programming, and we'll try to do some manual simulation so that I can can look at the behavior of the program and how recursive function programming works, right? On my previous video, I did discuss a program using recursive function programming, and if I am going to compare that video to this video is gonna be more technical and more complicated, right? But still, we'll be applying recursive function programming. Okay, so I'm going to share um, my notepad, right? I hope at the end of this video I'll be able to explain really the behavior of recursive program, and I'll be able to share my know-how on it, right? And you as viewers will be able to digest the concept, and along the way you can apply this technique in programming. Okay, so this is a problem. Design a program to ask for a positive number. All right, this line alone can be a separate function. All right, and then another one is compute for the sum of such series numbers. Another function again, but then the program is demanding us to use recursive function, right? So recursive function, we'll be asking for a positive integer value, and from this positive integer value will be computing for the sum of the number series of it. For example, the value is 5. Our program will compute for 1 plus 2 plus 3 plus 4 plus 5 and display it on the screen. And we'll be using recursive function instead of using loop, right? We'll be applying recursive function programming. Okay, so a very challenging topic, and I'll try my best to explain the program at a very low level, right? So that you can get it, right? And you can apply it in your programming life. Okay, so here um, I have three functions, and if you can see, the second and the third functions are actually common functions. I did share this kind of functions already in my previous videos, right? Get value, for example, this is common. Okay, and then void display, this is also common. When we are going to use void display, we are required to pass single parameter. And then this one, in some this is gonna be what this is actually this function will compute for the sum of the number series depending upon the positive number that is being entered by the user, or the yeah, while the program is running. And in here we'll be applying the recursive function program. We'll be calling in sum by its own. Okay, that's recursive. Okay, So here, this is our main program, right? So I declared two variables in here, number and result, because I'll be using these two variables as caller. Okay, will try to invoke a certain functions and make use of number and result as the one calling for a particular function. Okay, so the next line says number is equal to get value. So meaning our variable number is now trying to use get value. All right. So with this line, our C compiler will then search for get value function. So here, this one, and um, this is now the behavior of get value. It declares a single local variable named value, and then the next line is it displays what, enter a positive integer. All right, and then the next line is scanf, and whatever value that the user is putting in will be placed to and stored to value. Okay, for the sake of discussing, we'll try encoding 3. So when we press enter K, 3 is being stored to variable value, and return value means what? Pass back the 3 to the calling party. The calling party is number, so number now has 3. Okay, that number is equal to 3 is actually the result of return value in here, right? We are trying to return whatever is the content of variable value. Okay, so next here, result is equal to some number. So we are trying to use result as our variable that intentionally call for some function, and when we get in some function, we are bringing whatever is the value of number. Our number is how much? 3. So when we get inside sum, we are bringing 3. All right, so our compiler will look for sum here function, and this is our sum function, right? So our in, right, this one will receive whatever is our parameter that is being passed, which is number. Our number is 3, so good as we are passing 3 to n. And at any part of this function, if we tend to use n, then we are actually using 3, depending upon the commands inside, right? So with this one, for now the result value is still hanging, because we can only pass value to result, the calling, right, variable, if we're done with, right, if we have this return n or this kind of command. Okay, so here online is 3, right, and we are actually in here we are actually trying to say sum is equal to 3, right, and this kind of line will pass in here. That's why our in has a value of 3, because this 3 is being received by n. And here comes a condition, is our n not equal to 0, right? And in this particular example, our n is what? How much? Our n is 3, which is actually not equal to 0, meaning the condition is false. False, true. Huh? The condition is what? True. Okay, so true. Now since the condition is true, perform this one. If this condition is false, do not perform this one, but instead perform the else portion. So since it is true, so we have to perform this. All right, so here this is now the recursive function. All right, we are inside function sum, yet we are trying to call the function recursive, right? Recursive function programming. While we are within function sum, we are at the same time, okay, depending upon the result of this condition, we are at the same time trying to use the function sum. So loop. So recursive is actually synonymous to looping statements in ordinary program. Okay? Recursive programming is quite higher than the looping statement. Okay, so the now since the condition is true, we have to perform this. So meaning we are trying to say what? Return n plus, what is that? Sum, then followed by n minus 1. Good as we're saying, right? Return n, which is 3, plus, please follow my screen, plus sum, okay? And we are trying to say n, which is 3 minus 1. Are you following? Okay. Good as we're saying what? 0. Sum, no, not 0. 3 minus 1, that's 2. Okay, that's 2. And what's next? After performing this one, okay, after performing this one, this is now the complication of a recursive programming. Once the program is done complying or executing this one, it goes not perform in here because this is part of if. So since the condition is true, perform this one, and after that go to the curly brackets. When it goes into curly brackets, our C compiler will then go back to what? Here. Alright? It will goes inside in here. And prior to that, okay, look at this. Because this is recursive programming. So we are trying to return whatever is the value of n plus, right? So it will not goes back in here yet. Why? Because we have this recursive function. So plus sum is equal to n minus 1, meaning we are going to use in here. So our C compiler when execute this sum close open parenthesis n minus 1 close parenthesis means what? Goes back in here, meaning make use of this. And once it make use of this, right? Good as what? Our sum now, okay? Our in sum now is what? How much? Our in sum receive 2. Okay? Because n minus 1, 3 minus 1, that's 2. And 2. So when you see sum n minus 1, meaning you're good as you're trying to say make use of sum again, that's recursive, and pass 2. So this in here will receive 2. Are you following? And then look at this. So technical, but please follow my screen. Then our program will get inside this curly bracket, and it will ask again for condition. Is n not equal to 0? How much is our n? Our n is 2. Are you following? So is 2 not equal to 0? Yes. So meaning the condition is true. Now since the condition is true, what's next? Perform again. So it loops. Right? It loops. So recursive programming. And the line says return your n plus sum n minus 1. Good as you're saying what? Return your n, which is 2, plus your sum n minus 1, meaning 2 minus 1. And that's it, that is 1. Right? So again, since this is what recursive function, it will goes back in here. It loops. And once it loops, right, we are good as saying in sum 1. Right? Because sum 2 minus 1 is actually 1. So technical, right? But please, just be willing to digest and try to understand. Okay, you know, you can copy and paste this program, right? And run it to your online compiler and study. Be a scientist. Be a scientist. Right? Get tired of this. Tired you're thinking of this, but please don't get tired of yourself. Right? So here, another condition. Because you're getting inside again. Right? So the condition says is your n, which is how much? This time is 1. Not equal to 0. Yes, the condition is true. Now since the condition is true, what's next? Get inside and perform this one. Right? So return n plus sum n minus 1. Good as what? You are trying to return the value of n, which is 1. Right? Plus make use of the function again. And this time your n is 1 minus 1, that is 0. Okay? So you're in here. And when you say sum n minus 1, meaning you're good as trying to say sum 0. You're bringing 0 as your parameters and pass it here. Alright? So n now receive 0. Are you following? So int sum now contains, not 1 but 0. And then get inside the curly bracket and check if your n is not equal to 0. Your n is 0, right? And this time the condition is false, right? Because 0 is equal to 0. Then since this condition is false, what's next? Do not perform this one anymore. Do not perform. Instead, perform return n. Okay, return n. Now, so technical in here. When you say return n, right? You're good as you're saying return 0. Because our n is 0. Are you following? No, look at this. When you say return in here, okay, you're trying to say return 0. And this 0, right? And this 0 will be passed on to here. Alright? Why? This is how C programming language functions and behaves when you are trying to use recursive function programming. Okay? Deeper explanation of this, I don't know. Basta when you are going to use recursive function programming, this is how it looks like. Okay? When you say return 0, you're trying to return here. Alright? And when you say return 0, good as you're saying sum, close and open parenthesis 0. Alright? And return 1 plus 0, alright, is equal to 1. Are you following? Alright? And return 1 plus 0 is equal to 1. So this one will be returned, right? Because this is a return statement. So you're good as you're saying return 1 to here. Alright? Are you following? So return 1 to here. You're good as you're trying to say return 2 plus 1. Okay? Return 2 plus 1. And that is how much? 3. right? Return 2 plus 1, and that is 3. And this 3 will be returned in here. All right? Will be returned in here. Good as you're saying, return how much? 3 plus your 3 here. Where did we get this 3 here? Is from here. So 3 plus 3 is 6. And this 6 will be returned back to the caller, which is result. So result now contains 6. You're following. Now here, look at this. Once we're done with this, okay, it goes in here. Display result. When you say display result, you're trying to bring what is the result, the content of result. Now result contains 6. So our program, our compiler will be looking for display, right? And in here, it will pass, or it brings with it the value of the result, which is actually 6. Just so happen that the receiver is also named as result. So result now contains also 6. And print sum means what? Display sum is equal to %d, the data placeholder of result, which is actually 6. Alright? Question. Is it correct? You have 3 as your positive integer. 1, 2, 3. 1 plus 2 is 3, plus 3, that's 6. The sum is 6. This is correct. This is correct. Okay, this is correct. Oh, I hope uh, if you find it hard, congratulations. You're just trying to manifest that we're just an ordinary human beings. But then if you try to digest it, just be willing to digest it, right? This is so technical. This is so technical. Recursive programming is so technical. But please understand recursive function programming as a loop statement. It goes back and it goes back and it goes back. All right? And when it returns a particular value, it will return step by step. All right? So look at it here. When you say return 0, you're not going to return 0 to the caller directly. You'll be passing 0 to the next level, and to the next level, and to the next level, until such time you get 6. Are you following? Okay? So that's it. We'll try to give another example. Okay? We'll try to give another example. But then, here, say for example, we'll just try to erase in here. Okay? We'll try to erase. We'll try to erase. We'll try to erase. I'm sorry. We'll try to erase in here. All right. We'll try to give another example. Just a smaller value, because we're trying to save time. You know, when the value is too big, it takes a lot of recursive, right? It takes a lot of returns and returns and returns and returns. Okay. So we'll just try to to make use of some smaller number. So say for example, in here, we'll try to erase this one. Okay, I'm sorry. We'll try to erase this one, and we'll try to erase this one. Okay. So here, number is equal to get value. So number is trying to use get value, and number here is actually a variable, a caller variable, and this number is responsible for receiving value from the returned value of get value, right? So our compiler now will try to get inside get value, this one, right? And get value is now trying to display this. So it will display what? Enter a positive integer. Okay. And then, for example, it's 4. So 4 now will be stored to value, right? So value now contains 4. And when you say return value, meaning you're trying to return 4 to the caller, which is number. So number now contains 4. Then the next line says result is equal to sum. So again, result is actually a variable, a caller variable, and trying to call sum. And while trying to call sum, result is bringing the value of 4 number. So our compiler will get inside sum and pass 4. So meaning when it passes 4, the one received it is n, right? N. And from here, our program will get inside the body of sum, right? And it will ask, is our n not equal to 0? Right? Good as you're saying, is 4 not equal to 0? Of course, the condition is true. Now, since the condition is true, what's next? Return. Return n. So meaning, return your n plus sum n minus 1. Good as you're saying, return 4, right? Because our n here is 4. Plus, make use of sum again. Recursive. N is 4 minus 1. Right? And that is how much? That's 3. Okay? So when you say return n, you're trying to return 4, but you cannot just pass 4 in here. Why? Because we have a recursive function here. So prior to passing 4, we'll have to go back to the main, the sum function, and while going back to sum, bring 3. Because 3 is actually the result of n minus 1. 4 minus 1, that's 3. So when it goes back in here, good as what? We are saying int sum and bringing 3. Alright, are you following? And is your n, which is how much? 3, right? Not equal to 0. The condition is true. Now, since the condition is true, what's next? Return your n. Our n is how much? Our n is 3. Plus sum n minus 1. Our n is 3 minus 1. That's how much? That's 2. Right? So, we'll try to just place it here to make it easier to imagine. Right? So again, we cannot return 3 to the caller, right? Because recursive function programming demands us to go back to the sum function. And while we are trying to get back to sum, we are bringing 2 as a result of n minus 1, 3 minus 1. So when we get back, we are trying to say end sum 2. Our n receive 2. Alright? And then condition here. Is your n, which is 2, not equal to 0? Of course, right? The condition is true. Now, since the condition is true, what's next? Evaluate or execute this one. So, when we execute this one, we are trying to say what? Return n. Our n is how much? 2. Plus, go back to sum. And when you get back to sum, n minus 1, meaning 2 minus 1. And that's how much? And that's 1. Okay, 2 minus 1 is 1. So when you say return 2 plus sum, again and again, you cannot just pass 2 to the caller, which is result, because we have this recursive function. So it will go back to the function sum. And when it goes back, what happened? You're trying to pass 1, right? This one. Okay. So, when we are trying to pass 1, our program check if your n, which is actually 1, this not equal to 0. Yes, still true. Now since the condition is true, our program will get inside this line and execute. So we need to return whatever is the number, the value of n. Return n. Return n means what? Return 1 plus sum, right? In plus 1. 1 not plus 1 but minus 1, and that is 0. Okay, so again and again, you cannot just pass directly the 1 to the caller, which is result, because this is recursive, meaning we are demanded by a program to go back in here. When we go back, we are actually saying what? Sum, then we are passing parameter 0. Alright, and 0 is from here, 1 minus 1. And look at this. Is your n, which is 0, not equal to 0? This time, the condition is false. Right? If the condition is false, what's next? Do not perform this one. Bypass. And instead, perform the else portion. The else portion says what? Return n. Good as you're saying what? Return 0. Now, this is how recursive behave. When you say return 0, you cannot say return 0 to result. That should not be. Because the behavior of recursive function programming is it goes back step by step until it reaches to the top. Right? So when you say return 0, you're actually returning this 0 to the function in here. Okay? So meaning, as of this time, okay? As of this time, the value of this is 0. You're good as you're saying return 1 plus 0, and that is 1. And this return 1 will be received by the second level. So you're good as you're saying what? Return 2 plus 1, and that is 2 plus 1 is 3. And this return 3 will be received by this one. Alright? That one. So, when you say return 3 plus 3, right? Which is actually the value of here, that is how much? 6. Are you following? And return 6 means what? This 6 will be received by here. So when you say return 6, that's good as you're saying what? Return 4 plus your 6 in here, this one. And 4 plus 6 is 10. Now this time, this is now the topmost level of recursive. So you are trying to return 10 to the calling party, which is result. So result now contains 10. Alright? Now, next line, because we are now at the main program. Display result. Compiler will be looking at display and bring what? The value of the result, which is 10. And this 10 will be received by actually the same name but a different entity, result. So result now contains 10. Print sum, this one. So you're good as you're trying to what? To print what is this? Sum is equal to whatever is the value of result. Sum is equal to data placeholder, and this will receive the value of result, which is 10. Sum is 10. Question: is it correct? If your positive integer is 4, 1 plus 2 is 3, plus 3 that's 6, plus 4 that's 10. That's correct. Right. That is correct. Sum is 10. Okay. So the challenging part of this program is the recursive part of it. Okay. So I am hoping that I was I was able to explain the concept of recursive programming, function programming. Don't worry, I'll be posting several examples for programming problem that can be that will be using recursive function programming. Okay, so maybe by next day I'll be discussing other example again, and that's gonna still be a recursive concept. Okay, so please review this video as many as there's a need, right? Until such time that you are able to digest the concept, right? And just be open-minded. You know, programming is an art. Okay, so there'll be so many challenges, but then for as long as you're willing to take it, right? For as long as you're willing to tired your thinking, but please don't get tired. Then you learn. You learn. Okay. So thank you so much for watching this video. I hope you learned something today. Please click subscribe, please, and please share this video to your classmates, to your neighbors, to your friends, who are addict in programming, right? Especially to those who are beginners. Okay. If you're a beginner in programming, right? The best way to learn and to start is learn C programming language. Trust me. And once I'm done with all the topics in C programming, I'll be shifting to Python, for example. I'll be shifting to C++, or I'll be shifting to some other programming languages, Java or whatsoever, right? My target is I'll be making use of this channel as an educational YouTube channel, and meanwhile I'll be creating some video content that will touch the masses, right? I was thinking of yesterday I was thinking of having this video content that I'll be when I did hike, and I did last Sunday I saw this particular small house, and then there's one living in there, very old man, and when I look at him, I want to help that old man. So as yesterday I was thinking of helping him, and be part of my video content and be posted in here, right? And I am hoping that this plan will be materialized. In a way, we can help somebody or in need, right? Poorest of the poor. We can give them something to eat. We can give them something to cook, right? And in just a short period of time, because we don't have enough money yet, right? But once we're okay financially, then we give back, right? So that's my plan. I'll be having this YouTube channel as an educational channel, and at the same time a good Samaritan channel. That's that's my thinking right now. I hope I can make it true, right? I hope I can materialize the plan. Please subscribe this channel and share this to your friends. Thank you so much. God bless you. God is good.